This video is going to be covering question 6, part D from the 2021 AP Calculus AB free response no calculator allowed portion of the test. I cover parts A, B, C, and D in their own individual videos, so if you want to see A, B, or C, please check out my other videos. We don't need any of the original language from part 6 to do part D here. Part D is kind of its own separate little problem that has really absolutely nothing to do with the first problem. So let's dive into this and kind of decipher what all this is telling us here. So in here, we're being told that we've got this original function y equals b of t, and that function satisfies this differential equation here. So it has this derivative, is a fancy way of what they're saying. And then it tells us that off the original function, that when we plug in 1, we get out 2.5. Then the question itself is saying, is the rate of change increasing or decreasing at this specific time right here? Well, whenever I hear the term increasing and decreasing, that really takes me back to first derivatives, right? And as I try to decipher a problem like this, I need to go back to things that I'm comfortable with. So in your head, what you should be saying is, okay, if I'd had an original function that was my f of x function, and if I wanted to know where that function was increasing or decreasing, well, I would have found its derivative. And then I would have plugged in the number, and if that number in the derivative came out as a positive, if my derivative is positive, that told me that my original graph was increasing. If I plugged in a number and it came back negative, that told me that my original function was decreasing at that point. So let's try to use that logic to decipher what we need to do on this problem. So here they want to know when is the rate of change increasing or decreasing. They don't want to know when the original function is increasing or decreasing. They want to know when our rate of change, our derivative portion here, is increasing or decreasing. So essentially what we have happening right now is dy dt is behaving like our f of x graph. So if I want to know when that is increasing or decreasing, just like I had to find the derivative here, I need to find the derivative here. So d2y over d2 squared, I need to know, is that positive or is that negative? That's the question that I have to be able to answer. And if I can answer that, then that's going to tell me if my rate of change is increasing or decreasing. So let's go find the derivative of dy dt. So we come over here, we've got dy dt equals 3 minus y over t plus 2. Whenever you notice that you've got your variables kind of commingling into your problem here, that's bells and whistles got to be going off that you're going to need to be doing implicit differentiation. And that's what we're going to have to apply here. To find this derivative, we're going to have to use implicit differentiation. So I'm going to dt this entire equation. My little mantra, my little saying that I use when I'm doing implicit differentiation is every time I take a derivative, I get extra stuff. And what that extra stuff looks like is, envision there being this little dotted box on top here. And I fill that box in with whatever the letter is I took the derivative of. So I take the derivative like I normally would, and then my extra stuff is going to be d, whatever the letter is I took the derivative of, over dt. So let's work our way through our derivative up top here. So doing the first part, taking the derivative of our derivative, this is really just a notation game. This is d2y over d2 squared equals the derivative of 3, the derivative of a constant, no matter what method I'm using, is always 0. Then when I come to do this back piece here, what I'm looking at there is two chunks being divided. So when you're doing implicit differentiation, chain rule, quotient rule, product rule, all your rules still apply. So you have to look out for them. So whenever I've got two chunks being divided, I know that I need to apply my quotient rule. So my quotient rule recipe goes low, d high, minus high, d low, and all of that is over the low squared. You got to be able to just bust those rules out of your head as quickly as possible when you're taking this test. They just have to be second nature, your product quotient chain rule. So when we're doing implicit differentiation, the important part is, when am I taking my derivative and getting extra stuff as I do a quotient rule? Well, it's when I do the d high and when I do the d low that I'm actually taking a derivative and I'm going to get my extra stuff. So let's go ahead. I would label the top piece the high piece, the bottom piece the low piece. When you look at this and you got this negative out front here, go ahead and just attach that up to the y. It'll make your life a lot easier. So this is negative y over t plus 2. That's my high and that's my low. And now I'm going to start popping them into my derivative formula. So the first thing says first go grab the low piece. So I go grab the low piece, t plus 2. Multiply that by the derivative of the high. Well, the derivative of negative y would be negative 1. I took the derivative of a y, so I get a dy dt, filling that little dotted box in with a y because I took the derivative of a y. Then we get a minus from our rule. Go grab the high piece, which is negative y, and multiply that by the d low. The derivative of t would be 1. Took the derivative of a t, so I get a dt dt. And then the derivative of 2, the derivative of a constant, again, is always 0. And then all of that is over the low squared. So from here, what I need to be able to do is I need to be able to start plugging in values so that I can calculate out whether this derivative is positive or negative. And that's going to tell me if it's increasing or decreasing. Well, what do I need to be able to plug in? Well, I need to be able to plug in a t, and I need to be able to plug in a y for sure. That's where this information, the y and the t, come from the original function, right? When I plug in t, I get out y. So what this piece was telling me up here, this was quietly telling me that when I plug in 1, I get out 2.5. That's my t value, that's my y value. So I've got values for those. Then I can cancel out the dt dt. Anytime those things match up, it's like having 5 divided by 5. They cancel each other out, and that's just a 1. So I don't need to know anything about that. However, I do need a value for dy dt. Well, how am I going to figure that out? I have dy dt. Remember, we started with that earlier. And I have the point that's on the graph there. So I can take and I can plug that point into my dy dt, and that's going to get me a value out for that. So I would have 3 minus, and then on top I have a y, so my y value was 2.5. Then all of that is over t plus 2, so the t in this situation is 1, so I get 1 plus 2 on the bottom. And now we just got to kind of clean this up. We get dy dt equals 3 minus 2.5 over 3. And now this is where adding and subtracting of fractions comes in. I need to find a common denominator. So my common denominator on this would be 3. So multiplying the top and the bottom on the left, I would end up with 9 over 3 minus 2.5 over 3. And that's going to get me dy dt equals 9 minus 2.5 is 6.5 over 3. So I've got a value for dy dt, and I've got a value for t and y. And so now we'll come back over to this problem, and we're going to continue plugging in our values. Again, all we care about is positive or negative, but we still got to go through all this algebra to get there. So starting at the front here, plugging in for t, t is 1. So I get 1 plus 2. I've got the negative 1 sitting right there, and then dy dt is 6.5 over 3. We just calculated that value out. Then I get minus, I got my negative y, so y again was 2.5, and then we don't need the 1 in the dt. And then all of this is over, the t again on the bottom is 1 plus 2 squared. And now we just, again, algebra, algebra, algebra. You just got to follow it all the way through. Try not to skip any steps, because when you do, you're likely to drop a negative. So here we get, this is 1 plus 2 is 3. 3 times negative 1 is going to get us negative 3 times, we still have that 6.5 over 3. Then that negative negative is going to give us a plus 2.5. And all of this is over 1 plus 2 is 3. 3 squared is 9. Keep rolling the algebra, right? Keep rolling the algebra. Looking back at the front here, that's really negative 3 over 1. So that 3 can cancel out with that 3. That's going to leave us with a negative 6.5 on top. So we end up with negative 6.5 plus 2.5, and all of that is over 9. And then last move here, we just kind of bring this top together. We end up getting out that we have negative 6.5 plus 2.5 is going to get us negative 4.5 over 9. And that's as far as you need to go, because from that we can tell that what we're looking at is a negative value. And because it's negative, that's going to tell us that what was above it, dy dt, is decreasing at t equals 1. So what we get out here at the end is really just, you had to make the connection that, go back to what you know, f of x, to find if it was increasing or decreasing, we had to take its derivative. So if I want to find out if dy dt is increasing or decreasing, I need to find its derivative. And then I plug in a value. If it's positive, it's increasing. If it's negative, it's decreasing. And so in the end here, we got out that our second derivative was negative. That tells us that this is decreasing. And maybe at the end, you might do something, tell them specifically that you knew that this was negative, that this is less than 0, so it is decreasing at t equals 1. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.